High test scores do not matter if the system requires constant human intervention because it cannot evaluate its own mistakes mid-task. This outlines OpenAI's core thesis for GPT 5.5, an explicit shift from chat to autonomous, long-horizon execution. Instead of spitting out a single answer, the model initiates a multi-step sequence, parsing context, initializing tools, executing tasks, and verifying outputs. Completing that chain independently is the strict requirement. This compares the old chatbot structure with the GPT 5.5 coworker workflow. On the left, every AI output requires human error correction. On the right, notice the internal loop. The system invokes tools, tests results, and debugs its own code, entirely replacing the human step. Raw capability means very little if it comes with high friction. In this environment, true intelligence is measured strictly by how much actual work reaches completion before you have to touch your keyboard again. Historically, as frontier models scale up in reasoning ability, they incur a capability tax. They become computationally heavy, expensive, and noticeably slower to respond. These charts show GPT 5.5's performance on software engineering tasks. It hits higher completion rates while consuming significantly fewer output tokens. Crucially, it matches GPT 5.4's per token latency. Eliminating the speed penalty allows the model to function inside active workflows rather than slow overnight processing. For years, the industry judged AI models by having them answer static, multiple-choice trivia questions. But reciting memorized facts tells you almost nothing about whether a system can hold context, use software, and persist through a difficult assignment. These three evaluations represent a modern custom philosophy. They place the AI inside live, open-ended environments to see if it can operate actual software to get a job done. This table shows the model scores in autonomous code-based engineering. It achieves an 82.7% success rate on long-horizon terminal workflows and a 73.1% on internal engineering evals, proving it can manage large merges and debug across multiple files on its own. This chart tracks performance on economically valuable knowledge work. By scoring an 84.9% win rate, GPT 5.5 shows distinct strength in taking ambiguous business directives and synthesizing them into highly structured professional documents and spreadsheets. This data highlights native computer operation. With a 78.7% verified score in live operating systems and a 98% execution rate on complex telecom workflows, the model successfully chains multi-step tasks across entirely different applications. But data on a leaderboard have limits. Winning a controlled software evaluation is not a guarantee of flawless autonomy when deployed into chaotic real-world production environments. This graphic details those precise evaluation limits. Several of the highest engineering scores come from internal, non-auditable benchmarks, and public coding evals across all frontier models show ongoing risks of data memorization. This matrix outlines how the AI arms race is splitting into highly specific specializations. OpenAI, Anthropic, and Google are no longer building identical systems. They are prioritizing completely different architectural goals. This comparison isolates the primary rivalry. While GPT 5.5 dominates in broad execution, terminal workflows, and economic knowledge tasks, Claude Opus 4.7 retains a powerful lead in complex software engineering resolutions and enterprise tool orchestration. The concept of a single, universal AI that beats everyone at everything is over. The only metric that dictates which model wins is the exact type of workload you intend to run. This diagram shows how developers will interact with the 400K context window. Engineering teams will spend far less time writing boilerplate functions and instead transition to reviewing autonomous pull requests and orchestrating massive code-base-wide refactors. This flowchart maps the enterprise infrastructure scale. Businesses will push vast amounts of unstructured, messy inputs through the 1 million token API to generate automated, structured outcomes from massive document review and high-volume operational research. This schematic breaks down the daily gains for individual knowledge workers. By handling multi-source web synthesis and spreadsheet modeling simultaneously, the system drastically cuts down context friction, meaning far less time spent re-explaining instructions mid-task. The race is no longer about who can build the most compelling conversationalist. It is strictly about building the most reliable execution engine for real computer-based work. Intelligence is no longer measured by how cleverly a machine talks. It is measured entirely by the frictionless reality of the work it leaves behind.